Hi guys, here is day 2 of your notes. Hopefully day 1 went well. This might be a little longer than the last video just because it's a lot of graphing, but just bear with me. If you want to pause and come back to it, feel free. You don't have to watch everything in one sitting. All right, so again, if you want to print these notes out, that's fine and do it as we go. Or if you don't have a printer, you can just write on a separate sheet of paper. All right, so I'm going to start transformations of exponential functions. Now, yesterday we did f of x equals b to the x power. Now we have transformations. So there's an a in front. Okay, there's an x minus h in the exponent, and then there's a plus k. So those are all the different things that we have here. H, okay, h is going to be your horizontal shift. Sorry, I didn't put all right, horizontal. Again, I apologize for my handwriting on the computer. All right, if it is a plus, it's going to actually shift to the left. And if it's a minus, it's going to shift to the right. And you would think the opposite, and I'll explain why it is that way in a few minutes. All right, K is your vertical shift. Okay, so remember horizontal is side to side. If you don't know that, you can write that. Vertical is up and down. All right, plus means that it shifts up, minus shifts down, which is what you would expect. If A is negative, the function is reflected across the x-axis. Okay, so if there is a negative in front of this A here, then it's a reflection across the x-axis. Now, if the absolute value of A is greater than 1, it represents a vertical stretch. And if the absolute value of A is in between 0 and 1, it represents a vertical shrink. Okay. So basically, let me draw this over here, and you may already know this because of this over here, but I like to do this. If there is a negative in front of that A, that means it's a reflection. Okay, so if there's a negative in front of the A, that doesn't mean A is negative. Okay, A is going to always be positive, but if there is a minus in front of it, that means there's a reflection. Now, this here, okay, represents whether it's going to go to the left or to the right. So in the exponent represents whether it's going to go to the left or to the right. Now, after the plus k, that represents whether it's going to move up or down. Now, it may do all of these things. It may be a reflection. It may go up, down. It may go left, right. You may have this A tells you whether it's going to be a vertical stretch or shrink. So let me actually try and squeeze that in there. All right, so it may have all of these different transformations, or it may just have one, okay, one of these. It doesn't have to be all, it could be 2 out of them, okay, and you'll see that in just a few minutes. So this is a lot. You can watch this. Luckily, this is a video. You can replay it over and over. You can take notes, write your own notes, whatever you need to do in order to understand this. So for 1 through 4, it says A to identify the parent function. Remember, the parent function is y equals b to the x power. And then describe the transformation. So for number 1, okay, remember it's, and I'm going to write f of x. If you want to write y equals, it's the same thing. Equals, it's this 3 to the x power. That's your parent function. The plus 5 is a transformation. Your original function is 3 to the x power. So that's your parent function. That's what it's asking you. Now describe the transformations is b. All right, so this 5 here, all right, this plus 5 is whether you go up or down. Remember, this plus is up or down. Now, since it's plus, if you look back up, that means it's going to go up. So it's a vertical shift up, and it's 5 units because it's plus 5. And that's it, because there's only this plus 5. This is a parent function here, so anything other than the parent function that's there, that's what the transformation is, and there's only one there. So over here, number 2, the parent function is f of x equals. Now, it's the parent function is whatever with the x as the exponent. So that would be this 1/4, and you don't I guess you could put it in parentheses, that'd be better, to the x power, okay? Do not put the -1, okay? That is a transformation that's saying that it's either going to the left or to the right 1 unit, all right? And this 2 tells whether it's a shrink or a stretch, okay? So the 1/4 to the x power is the parent function. Now b is where we can talk about the 2 and we can talk about this -1 here, all right? So for the 2, okay, if you look, the absolute value of a, your a is 2, the absolute value is greater than 1, okay? So it's a vertical stretch. All right, and then also, since this here is x minus 1, it says up here, h, that's your h, and again, you can go look up here, x minus h, okay? So this 1 is your h. If it's a minus, it's going to shift to the right. So it's going to be a horizontal shift to the right, 1 unit. Now let me tell you why it's to the right and not to the left. If you look at it, it looks like -1. You would think it would go to the left. However, if you look up here, it's x minus h, right? So if I did x minus h, I'm just going to rewrite it. We have x minus 1, so x minus 1. What is your h here? Is it 1 or is it -1? It is just 1. So since it's really a x minus a +1, it's going to the right 1 unit. And if that doesn't make sense, I'm going to do it again for the next 2. So hopefully after that, it'll make more sense. All right, so moving right along. So number 3, again, your parent function. And if you want to try these on your own, pause the video, try them on your own, and then just watch as I go and see if you get them correct. That's what I would highly recommend. So here, parent function, f of x equals, okay? Not the negative, that's one of our transformations. It's going to be the 4/3. And again, to the x power, because this number goes with this x, okay? Not the +2, not the +7, not the minus, okay? Those are all transformations. So the parent function is f of x equals 4/3 to the x power. Now, b, we have 3 different transformations here. This negative means that it's a reflection over the x-axis. Okay. Now this +2, again, I'm going to rewrite the x minus h. Now, in order to get this to +2, it has to be x minus a -2, because doesn't minus and negative make a positive? Okay, so that's what it is. So your h in this case is really a -2, which means it's going to the left. Okay, that's why if you see a plus, it's going to the left. All right, so this is a horizontal shift to the left too. All right. Now the last one is this +7, and again, if it's plus, it's going to be, and if it's at the end, it's a vertical shift, and it's 7 units up. Okay, and it's up because of this plus. All right, so next one, parent function. Okay, it's whatever's with that x as the exponent, so it's 5 to the x power. And then for our transformations, we have this 1/2 here, all right? So again, the absolute value of 1/2, okay, is 1/2. So it's between 0 and 1, which means it's a vertical shrink. All right, then we also have this -4 here. So again, if I had x minus h, that's the equation, then you have x minus 4, okay? That's part of your equation. Now, the h is 4, so that means it's a +4, which means it's moving to the right 4 units. So this is a horizontal shift right 4 units, okay? All right, so horizontal shift right 4 units. I apologize for my handwriting on here. It's horrible. All right, and then -2 is going to be a vertical shift, and because it's minus, it's going down 2 units. Okay, so I know it's hard to remember all these things, okay, but hopefully over here, you can remember, you can write this down, look it over, okay, always reference it. All right, now, Hopefully you know how to use Desmos. If you don't, I did type in all the equations just so I could save you some time. I can, if you want me to make another video on how to use Desmos, just let me know. All right, so number 5, okay, it says to graph each function and identify its key characteristics. So we're gonna identify all these, some of this stuff we did yesterday. So f of x equals 2 to the x plus 5 power. So I did that over here, okay? F of x equals 2 to the x plus 5 power. Make sure the x plus 5 is in parentheses, okay? So here is the table that they gave us, okay? And if I go back, all right, I'm gonna make my table. All right, and my table, before I actually do that, so if I look, all right, I would only be able to plot one of these points on here, right, on our graph. So I want to make sure that I choose numbers over here that I can put on the graph. So if we go back over here, in order to do that, look at whatever number is in the exponent, okay? And remember, this is really x minus a negative 5, okay? Because x plus 5 means it's x minus a negative 5, and the form of our part of your equation is x minus h. So you always want it in x minus. So you know your h is negative 5. So that's always going to be the middle number that you want to use, okay? So negative 5, you could do negative 6, negative 7, and negative 4, negative 3. So do 2 points on each side. So those are the numbers that I want to use. So if I go over here, I know negative 2 is 8. Okay. Oh, I didn't even do negative 2. All right. So let's type these in. So negative 3. Okay. Don't worry about the numbers underneath. Negative 4, negative 5, negative 6, and negative 7. Okay. So hopefully you can't hear my son screaming in the background. All right. Here are the numbers that we want to plot. So negative 3, 4. All right. Negative 4, 2, negative 5, 1, negative 6, 1/2, and negative 7, 1/4. Okay, those are the values that I want to go ahead and plot over here. So 1, 2, 3, 1, 2, 3, 4, negative 4, 2, negative 5, 1, negative 6, 1/2, negative 7. Okay, so here's this. Remember from yesterday, our asymptote, okay, you don't want to cross that line. Okay, so you do not want to cross this. Now this may change, okay, and you'll learn that. So our domain is always going to be the same for these problems. It's all reals because this is going to keep going. It's going to eventually get to positive numbers. So you have positive numbers and you have negative numbers, so it's all real. Your range, all your y values are greater than 0. Okay. End behavior, as x approaches infinity. So as your values, your positive values, okay, approach infinity, okay, what happens to your y values? Well, they keep going up and up and up and up and up, so they approach positive infinity. Now, as your x values get negative, okay, what happens? Well, look at your graph. It continues to get closer and closer to 0. All right. Now your y-intercept, does it give you your y-intercept over here? It does not, but if you go over here, you can see that at 0, your y value is 32. Okay, so this would be 0, 32. Now, if you don't have a calculator, how could you do this? You could substitute in 0 here. 0 plus 5 is 5. 2 to the 5th power is 32. That's where this number comes from. Same thing if you don't have a calculator to do this table, you can still do this. It might be a little more difficult, all right? But you have negative 3, okay? Substitute in a negative 3, okay? Negative 3 plus 5 is 2. 2 squared we know is 4. That's how you get these numbers. Next, your asymptote. Your asymptote is right here, which is just y equals 0. All right, now, next one. I already typed this in. Like I said, let me get rid of this one. Let's leave. Okay, I already typed this in here. Okay, make sure 1/3 is in parentheses when you do it. Make sure this minus 2, after this x, you want to arrow over so that the minus is no longer in your exponent, okay? Now, for this one, if we look, okay, we don't have anything with our exponent, so we're going to use -2, -1, 0, 1, and 2. So anytime it's just x, just like yesterday, you're just going to use -2 to +2. All right. Now I'm going, actually, I don't even have to do that. Okay, so I wrote these all on a piece of paper, so I don't have to flip back and forth. So we have -2, 7, -1, 1, 0, -1, 1, -1.6 repeating, and 2, -1.8 repeating. Okay, so let's graph these. All right, -2, 1, 2, 3, 4, 5, 6, 7, -1, 1, 0, -1, 1, -1.6, and here's this. Now notice that unlike yesterday, this goes below our x-axis, okay? Now, in order to find what your asymptote is, look at this number, okay? If you look above, we didn't have anything after this, so our asymptote was y = 0. This has a -2. That's also, besides telling you it's moving down to, this is also your asymptote, where your asymptote is. All right, so what I usually do, and I didn't do it here because you didn't know yet, I draw this in first. That tells me when I'm making my graph, I can't go below that line or above, depending on what your graph looks like. So we can already fill in that our asymptote is y equals a -2. All right, your range, or sorry, your domain is the same, okay? All real numbers, you have positive values, positive x values, negative x values. Now your range, everything is above -2, not 0. Everything is above -2 now. So y is greater than -2. All right. Next, end behavior. Hopefully you guys are good on end behavior. The more we do it, hopefully the more you understand it. So as x approaches infinity, so all of these positive values, what's happening to your y value? Well, your y value, if you look at your graph, it keeps getting closer and closer to -2, your asymptote. As x approaches negative infinity, so here are your negative numbers. What's happening to your graph as x gets more negative? Well, it's getting more positive, so it goes to positive infinity. Your y-intercept is given over here at 0, so it's 0, -1. Okay? All right, next. All right, we did that one. Let's leave. Okay, next one. So again, I already typed this into our graphing calculator. And if I made any mistakes, just let me know. I did this kind of quick. So since there, again, is nothing with our x value here, all right, what you want to do is do your -2, -1, 0, 1, 2. Oops. Oh, I stopped writing again. I did this yesterday. All right. 2. Okay. So our values, again, you can see how I typed it in. Make sure the 1/2 is in parentheses. Then you can just do your 3 to the x power and then the +1. Okay. And I'm going to write these in. So we have 1.05 repeating. Just the 5 is repeating. -1 is 1.1 and just the 6 is repeating. 0 is 1.5. 1 is 2.5. And 2 is 5.5. All right. So when we graph this, all right, remember I said I do the asymptote first. So this is going to be your asymptote. It also tells you that you're going up 1, but it also tells you what your asymptote is. It's at a +1. So y equals +1 there. So again, your asymptote you can already write in. So if you do this, -2, 1.05, -1, 1.16, 0, 1.5, 1, 2.5, and 2 is 5.5. 1, 2, 3, 4, 5.5. Okay, so again, you don't want to draw this line under the asymptote. It cannot cross that asymptote there. So again, your domain, hopefully we all know at this point, is all real numbers. Range. Everything is above what line? The asymptote, which is 1. So it's y is greater than 1. And behavior. So as x approaches positive infinity, what's happening to your graph over here? Well, it continues to go up, so it's going to positive infinity. As x approaches negative infinity, so what's happening to your graph over here where your x is negative? Your graph is getting closer and closer to 1, okay? And then your y-intercept is over here. It's 0, 1.5. Okay, hopefully you're getting the hang of it now. I didn't want to go through and do all of these examples with you, but the more I looked at them, I figured they all had something different. So I figured I had to do them. So sorry. All right. Next. This has something other than x in the exponent. So this will tell you what value you want in the middle of your graph here when you're graphing. Otherwise, you're going to get some numbers that are like way up here or maybe way down here, and you can't see the whole graph. So here, this is x minus 4. So remember, your h is actually 4 because it's x minus your h. Your h is 4, so you want 4 in the middle. So you can pick 2 above and 2 below. So I'm going to do 5 and 6, and I'm going to do 3 and 2. All right, so did I already x out of this one? No. Let me x out of this one. All right, so your next one. 3 halves in parentheses. Make sure your x minus 4 is in parentheses. Make sure you arrow over so that this minus 5 is no longer in your exponent. So I said that 4 needed to be in the middle, right? So we did 6. Oops. Let me redo this because I just messed it up. So we did 6, 5, 4, 3, and 2, I believe. Yes. Okay, so there's our numbers there. So I'm going to go back. All right, and 6 is negative 2.75. 5 is negative 3.5. 4 is negative 4. 3 is negative 4.3 repeating. 2 is negative 4.5 repeating. Okay, so there's those values. Now, also, what I didn't say is you can always go back to Desmos and make sure that you graphed it correctly, because sometimes people make mistakes. Sometimes you may put a dot up here, then you may go put one here and you're like, I did something wrong. So make sure that when you actually reference the calculator, you make sure it looks just like this. All right, so here, we already talked about this. This is our asymptote, right? So that's negative 5, so y is negative 5, and I can draw that in. 1, 2, 3, 4, 5. So an asymptote, I don't think I ever said, but you can obviously see it's a dashed line, so make sure you're not drawing solid lines. All right, now that we have the asymptote in, we can go ahead and graph these points here. So we have 6, 1, 2, 3, 4, 5, 6, negative 2.75, and again, they're not going to be exact. 5, negative 1, 2, 3.5. 4 is negative 4. There we go. 3 is negative 4.3, and 2 is negative 4.5. Okay, so close enough, right? So again, I haven't said it. I'm surprised I haven't said it yet. Usually I say this a lot. Make sure you have arrows on both ends. Now, domain, range, domain, all reals, okay? Range, what are all of your y values above? Well, they're above the asymptote, which is negative 5. So y is greater than negative 5. And behavior, as x approaches a positive infinity. So as your x values are positive, what's happening to your graph? Well, it's going up. So your y values are going towards positive infinity. As your x values are negative, so this part of the graph here, what's happening? Well, your graph is going closer and closer to negative 5. All right, your y-intercept is when x is 0. Do we have 0 here? No. Okay, so what you want to do is look at where 0 is here, and I would just round. So negative 4.8 is fine. I think I put negative 4.802 on mine, but it's totally fine. So 0, negative 4.8. Okay, so there's that. Again, if you don't know how to do that, without a calculator, substitute 0, and then go ahead and do the math. That's going to be a little more difficult, but you can do it. Number 9. All right. Since we have something in our exponent here, remember, you got to figure out what your h is. So since it's x minus 2, your h is 2 because it's x minus h. H is 2, so that's going to go in the middle. You want 2 points above, 2 points below. Okay, so there's those points there. Now, is there anything, I'm getting ahead of myself. Let me do this though. Is there anything after this like there was up here? There is not. So what does that mean? That means that our asymptote is 0. Okay, if you wanted to write plus 0 after it, you could. That would be your k value. So we know our asymptote is 0. Okay, so let's go to our calculator. Let me get rid of this one. Okay, and the values that I use are 0 through 4. So we are just going, since I already have 0, 1, and 2, I'm going to do 3 and 4. Okay, obviously 4 we're not going to be able to graph here. But, all right, here we go. So 0 is negative 0.125. 1 is negative 0.5. 2 is negative 2. 3 is negative 8. 4 is negative 32. Obviously, we can't graph that, but it's there. So domain, all reals. Maybe I keep getting ahead of myself. Sorry, guys. Let's graph this. 0, negative 1.25. All right. 1, negative 1/2. 2, negative 2. 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And obviously I can't graph the other one. Now, what do we notice about this one? Did I graph it wrong because it's upside down? Okay. Hopefully you realize that the reason it is upside down or a reflection over the x-axis is because of this negative here. So that means it's going to be a reflection. So usually they're above the x-axis. Because there's that minus there, it flipped to below. Okay. Also, what I haven't really been talking about, and I'll go through in just a minute, this minus 2 means it's actually going to the right 2 units, okay? So whatever your value was that was on your that was your y-intercept, it's actually moved to the right 2 units now, okay? Let's see. All right, so back to range. So for our range, now we're not going to do y is greater than, right? Because we have nothing that's greater than. Everything is less than 0 now. So be careful when you're doing the range, okay? You really have to pay attention. It's less than 0 now. For end behavior, as x approaches infinity. So as your x values are positive, okay, what happens to your y? Well, they're not going up, right? They're going down. So it's negative infinity. So be careful. Okay. Now, as x approaches negative infinity, what's happening to your graph? It's getting closer and closer to 0. Then your y-intercept is here. Okay, 0, negative 0.125. All right. And that's it for notes. Let me just go through one thing that I wanted to show you. I didn't really talk about any of the transformations as we were graphing, but you can look. So this means that you are going to the left 5 units. Notice it's to the left, okay? This means you're going down 2 units. Notice your graph is down 2 units, all right? This means that, and these are harder to see, but this 1/2 means that your graph is shrink. This means your graph moved up 1. Okay, this over here, this over here, your graph is moving to the right 4 units. So notice that it moved to the right. -5 means it went down 5, okay? The only other thing that I want to point out before I go is the growth and decay. So since this is a 2, that's greater than 1, so it's a growth. This is 1/3, it's less than 1, so it's decay. Okay, always look at these things. You may graph something like this and it might be wrong, okay? So you always have to pay attention, double check your work. So since this is a 3, we're not looking at the 1/2. Since it's a 3, it's a growth. This is a 3/2. That is not less than 1. 3/2 is 1.5, so that's also growth. Okay, now this is the only tricky one. It's a 4, so it's a growth. So it would look like this if it didn't have the minus in front. So it's a reflection, so you just flip it over. All right. Hopefully there aren't too many questions. If there is, feel free to ask. I'll make another video explaining whatever you guys need me to. All right. I hope you guys do well on the homework. Work on the homework, ask lots of questions. I think I can send individual videos as well to help you out. So just ask all your questions. I did put a post for you to ask any of your questions. If one of your classmates wants to answer them, make sure that if you know the answer, you answer the question, because I'm going to be giving extra credit. I will not give extra credit to someone who doesn't have a good answer to, the question. However, try your best. I do want you guys to communicate with each other as well, not just me. So try answering other people's questions if you have them. All right. I'll talk to you guys later.